Shri Sai Ram. And today we are going to start exercise 4.6 as we have done some problems already from the exercise 4.6. Today we will continue that, and what we have learnt yesterday is we learned to find a solution of a system of equations by using matrix method. And here we have two system of equations which are linear equations, understand. So with using matrix method we are going to find what are the values of these variables x and y, and we can represent simultaneous equation in matrix form. We can represent this linear equations as we can represent in the form of Ax is equal to b, understand, where A is matrix, X is matrix and B is matrix, but we have to write what is A particularly and what is B and what is X. So we have to write all these things. Now here how you are going to write A is, so you just write the coefficients of the variables. Okay, here what are the coefficients of the variables? 2, and what is the coefficient of y? Minus 1. Okay. So similarly for the another equation, what is the coefficient of x and y, which are 3 and 4, that gives the matrix A. Okay. Similarly what is x? X represent matrix which contains variables x and y. Similarly what is B? B is the constants 2 and 3. Okay. So now for this what you can do is, now we have to find actually we have to find the values for x and y here. So how can you find that? I can write x is equal to A inverse into B. I can rewrite this equation like this. Now you can call it as 1. Now what you can do is we can find A inverse. Already we know that what is B. So from the given equation we have written matrix B. Now we have to find A inverse. How can you find A inverse? As you know that formula, A inverse is equal to 1 by determinant of A into adjoint of A, where adjoint of A is nothing but the transpose of cofactor matrix. Okay. So by using this formula we are going to find A inverse. See, to find A inverse we should follow that A should be non-singular. That means the determinant of that matrix is not equal to 0. That we should keep in our mind. So now we have to find determinant of A. What is determinant of A? Take the determinant on both sides of this matrix. You are going to have determinant of 2 minus 1 3 4. You just expand it by taking product of diagonal minus product of non-diagonal. That is 2 into 4 is 8 minus of minus 1 into 3 is minus 3. What is this? 8 minus into minus becomes plus. Therefore the determinant of A is 11. Okay. Now we got the determinant of A. Now we have to find adjoint of A. See, I can write adjoint of A in such a way that first I will write the cofactor matrix, understand. See, for this I will take transpose, then it will becomes adjoint of A. Okay. So here to find this entry you delete the first row and first column and take the other element over here 4. Similarly where this entry lies, which lies in the first row and second column, you just delete that, and what you left 3, and here delete the first column and second row, we will have minus 1, and here delete the second column second row, what you left 2. Therefore we can write adjoint of A is equal to, take transpose of this, okay, that gives adjoint. So that is 4 minus 3 minus into minus 1 is plus 1, and this is 2. See, we have transposed it, interchanged or flipped, we can say 4 3, first column. First row become first column, second row is 1, 2. So, it becomes second column. This is what adjoint of A. Once you find the adjoint of A, so we can find A inverse. What is A inverse? 1 by determinant of A into adjoint of A. What is this? A inverse is equal to 1 by 11 into adjoint A is 4, 1 minus 3, 2. Okay. Yes. So, we got the A inverse. Now, we have to find X, matrix X. Okay. See, by equation 1 becomes, so what is X? X is a matrix. I will write down what is X just later. So, now what is A inverse? 1 by 11, 4, 1 minus 3, 2. Here generally what students can do is, once they got A inverse, they simply multiplies this to the every entries of the matrix. Kindly do not do it. So, what you can do is, so after multiplying A inverse into B, you keep this 1 by determinant of A as it is. Once you multiplied with B, at the end you can multiply that. Okay. And what is B? B is 2, 3. So, you first you multiply this, after that you can multiply 1 by 11 to each entries. Now, X is equal to 1 by 11. Now, you just multiply 4 into 2 plus 1 into 3 minus 3 into 2 plus 2 into 3. So, what is this? This is equal to 1 by 11 into, what is that? 11 plus 6 minus 6 vanishes. So, we end up with 0 for that entry. And what do you have on LHS side? What is X actually? X is XY, matrix XY, column matrix, which is equal to 1 by 11 into matrix 11, 0. Now, you multiply this. 1 by 11 into 11, it will cancels 11 by 11. So, you end up with 1. So, 0 by 1 by 11 into 0 what? Okay, 0 into anything will become 0. Okay. So, now we got two equal matrices, xy is equal to 1, 0. By this we can conclude that x is equal to 1, the corresponding elements are equal. See, the order of this matrix is same as the order of this. So, we can equate it, understand. So, x is equal to 1 and y is equal to what? 0. So, now here we got the values of x and y. So, once you got the values of x and y, you can verify by substituting these values in any one of the equation which is given. Similarly, we will try another problem. Here, solve the system of equations by matrix method. You take minus, you will see 2x minus y is equal to minus 2, 3x plus 4y is equal to 3. So, we can write this in the matrix form as Ax is equal to B, where what is A? A is 2 minus 1, 3, 4, and what is B? B is minus 2, 3, and x is xy, understand. So, here we can find the determinant of A. What is determinant of A? 8 plus 3, which is 11. Therefore, determinant of A is 11. So, after finding determinant of A, we can find what? A inverse. Since we can write this, x is equal to A inverse into B. Okay, I can call it as 1. So, now we have to find A inverse, and after finding A inverse, we have to multiply that with B. What you can do is, before finding A inverse, I have to find adjoint of A. So, what is this? Plus, minus, minus plus, and you take the transpose of this. Okay. What you can do is, if you take the transpose, it becomes adjoint, right? This is a cofactor. If you take transpose, it becomes what? Adjoint. Now, what is this? 4, 3 minus 1, 2. Now, what is adjoint of A? That is 4 minus 3, 1, 2. This is adjoint of A. Now, after this, what you can do is, we can find A inverse. Okay. What is A inverse? 1 by determinant of A into, what is that? The adjoint matrix. What is adjoint matrix? Adjoint of A. So, you can use that here. A inverse is equal to 1 by determinant of A is 11, adjoint of A is 4, 11 minus 3, 2, which is similar to the previous example. The only change is we have taken one of the constant as minus 2. It lead to a different problem. Okay. So, now what you can do is, equation 1 becomes now, what about equation 1? X is equal to A inverse. What is A inverse? 1 by 11 into 4, 1 minus 3, 2 into, what is that? B minus 2, 3, with this 1 by 11 into minus 8 plus 3, see, minus 8 plus 3, and is 6 and plus 6. So, now what is the answer is 1 by 11 into, what is this? Minus 5, and this is 12. So, you can multiply 11, 1 by 11 to each of the entry, that is minus 5 by 11 and 12 by 11. So, on other side we have x. What is x? X is nothing but their matrix xy. So, matrix xy is equal to minus 5 by 11, okay, and what is that? 12 by 11. Hence, this implies that the value of x is minus 5 by 11 and the value of y is, what is y? 12 by 11. So, this is how we can find we can find the values of x, y, z. That gives the solution of simultaneous equations. Okay. This is regarding to second order. Okay. So, next we can solve the third order as well. We can see that problems. Yeah, here there are 3 variables, as well as if you wanted to solve if you wanted to find the values of 3 variables. So, we must require at least 3 or more than 3 also, it can be possible, but we should have 3 equations to solve 3 unknowns. Okay, unknowns here is variables. So, now here x, y, z are the variables. There are 3 simultaneous equations. With this we can able to find the values of x, y, z. Okay, understand? Now what you can do is, I can write the given system of equations in the form of x plus b. So, x is equal to b. Now, how can you write what is a, x and b is, where a is, what is a? You simply write down this is in the standard form. Okay. Yesterday in the last class we have discussed that. Suppose if the simultaneous equations are given like this, x minus y plus 2z minus 7 is equal to 0. So, we have to rearrange the equations in the standard form, then only we can able to write in the matrix form, that is x equal to b. So, now, so what is this? 1 minus 1, 2, 3, 4, minus 5, 2, minus 1, 3. And what is x? X is a matrix of variables x, y, z. Now, and what is b? B is, what is b? 7 minus 5 and 12. This is what we have, right? So, now I can rewrite this equation as x is equal to a inverse into b. I can call it as equation 1, and equation 1 gives the solution of the given simultaneous equations. So, now what you can do is we have to find A inverse. So, as you all know that what is A inverse? 1 by determinant of A into adjoint of A. Okay, this is what we have to find now. So, for that we have to find adjoint of A. So, you are familiar with finding adjoint of A, plus, minus, plus, and here minus, plus, minus, and here plus, minus, plus, and take transpose. This is a cofactor. If you take the transpose of this, it gives rise to a adjoint of a matrix. So, now be careful, and so be conscious about this finding cofactor matrix, because here itself the solution may changes. Okay. So, be conscious while finding this. So, now we have to find it. Now, we have to find this entry from this matrix. Now, how we can find out that? Where this lies? This lies in the first column and first row. So, now here delete that first row, first column, and take the transpose of this, and take the determinant of this. What you can take, what is the determinant of this? 4 into 3 minus 5 into minus 1, 5. Minus 5 into minus 1 is 5. 12 minus 5, 7. Understand? Next, similarly, now we need to find this entry. You just delete the first row, second column. 3 into 3, 9, minus 5 into 2 is minus 10. So, the answer is 19, plus 10 plus 9, which is 19. Next entry, this one we have to find. Delete the first row, third column, take the determinant of 3, 4, 2 minus 1, that is minus 3, okay, 4 into 2, minus of 4 into 2, minus 8. What is the answer? Minus 11. So, write down here. Okay. Similarly, you can find, so here for this entry, what you can do is delete the first column and second row. What is this? Minus 1 into 3 is minus 3, minus of 2 into minus 1, which is minus 2. Okay. So, what is this? Minus 3 plus 2. What is the answer? Minus 1. Okay. So, now we have to find this entry. You just delete the second column, second row, 1 into 3 and minus 4, minus 1, minus 1. Here delete the third column and second row, 1 into minus 1 is minus 1, minus 1 into 2 is plus 2. What is the answer? 1. And what is this? Minus 3 minus 8, which is minus 11. Okay. Understand? So, if you wanted to find this, what you can do is you just delete the first row, third column, and take the determinant of this. 3 into minus 1 is minus 3, minus of 8, minus 3 minus 8, minus 11. So, this one, delete the first column, second row, minus 1 into 3, minus 3, minus of plus 2, minus 3 plus 2 is minus 1. Next, and this one how can you do? Second row, second column, 1 into 3 is 3, 3 minus 4, minus 1, and this one, minus 1, minus of minus 2, minus 1, this one, minus 1, minus of minus 2. Understand? Delete the second row, third column. What are the elements we left? 1 minus 1, 2 minus 1, 1 minus 1, 2 minus 1. If you take the determinant of this, 1 into minus 1 is minus 1, minus of minus 1 into 2 is minus 2. What is the answer? You are going to have minus 1 plus 2. The answer is plus 1. Okay. That is how we can calculate the entries to find adjoint of A. Be careful while finding this, so you may confuse us. Okay. Practice on this. Next we have to find this entry. How are you going to find this entry? Where this entry which lies is first column, third row. So, and take the determinant of this, minus 1, 2, 4, 5. So, what is that? 1 minus 1 into 5 is 5 minus 8. What is the answer? Minus 3. Next is what? This one, right? This is what we have to find from this matrix. Delete the third row, second column. 5 minus 5 into 1 minus 5. 2 into 3 minus 6 minus 11. So, this is minus 11. Next, so that is minus 11. Next, this one, how can you do it? Third column, third row, delete it. 1 into 4, 4 minus of minus 1 into 3 is minus 3. So, which gives to 4 plus 3, which is equal to 7. So, this entry is 7. So, now we got the what? The adjoint of a matrix A. Now, what you can do is, you can take the transpose of this, understand, that gives adjoint of A. So, once if you take transpose of this, 7 and minus 19 and minus 11, understand, minus 1 into 1, 1, plus minus 1, minus 1, minus 1, and here plus minus 3, minus 3, plus 11 and plus 7. This is the adjoint of A. Okay. So, next what you can do is, so you can find A inverse. Now, we got adjoint of A, still we have to find A inverse. Yeah, we got adjoint of A. Now, we can find determinant of A. What is determinant of A? You can take the determinant on both sides of this and expand it along first row. So, I will expand it along first row, that is 1 into, delete the first row, first column, 4 into 3 minus, minus 5 into minus 1 is 5. Okay. Minus of minus 1 become plus 1 into 3 into 3, minus of minus, it will become plus 19. And then what you can do is, you just delete the first row and third column, it will be plus 2 times of minus 3 minus 8. Okay. So, now what you can do is, determinant of A is equal to 12 minus 5 is 7 plus 19 plus 2 times minus 11. So, here it will be equal to 7 plus 19 is 26, 2 into minus 11 is minus 22. So, answer is 4. Anyhow, the determinant is not equal to 0. In the beginning only we discussed that. So, if determinant is not equal to 0, then only we can able to find inverse of A. So, here we got determinant of A is what? Determinant of A is 4. Okay. Now, we can find by equation 1 implies that, what is that? X is equal to A inverse into B. So, as you know that what is A inverse? So, 1 by adjoint of A in 1 by determinant of A into adjoint of A into B, which is equal to 1 by 4 into adjoint of A is 7 1 minus 3 minus 19 minus 1 11 minus 11 minus 1 7 into, what is that, 7 minus 5 12. So, now you multiply this, do not multiply this 1 by 4, at the end you can multiply, otherwise it makes difficult for us. 7 into 7, 49, minus 5, minus 3 plus 12 minus 36, 12 3 is a 36, minus 133, 7 19 is a plus 5 plus 5 plus 11 12 is a 132, this minus 77 plus 5 and plus 84. So, what is that? 7 into 12, 84. So, that is equal to 1 by 4. So, you can simplify 49 minus 48, 8, 1 minus 133 plus 132 is minus 1, minus 1 plus 5 is 4, and here minus 84 plus 5 is 89, 89 minus 77 is 12. Okay. So, this is equal to, now you can multiply 1 by 4 to each entries. So, now it becomes 4 by 8, 4 by 4, 12 by 4, 12 3s, 4 1s are 4 3s are, 4 3s are 12. Now, what do you have on LHS side? Capital X. What is capital X? X, Y, Z. So, now these two matrices are equal, right? So, now you can equate it, each entries you can equate it, corresponding entries. X is equal to 2, Y is equal to 1 and Z is equal to 3. Okay. This is how we can calculate the values of x, y, z. That gives a solution of the linear system of equations. Okay. Similarly, we will try another example. Yeah, this is one more example which we have to solve now. See, now the system of equations they have given, now we have to solve this by using matrix method. So, first we have to write this in the form of Ax is equal to B. Okay, what is A? Where A is matrix, write down the coefficients from this 1, minus 1, 1, 2, 1, minus 3, 1, 1, 1. What is B? B is 4, 0, 2. Now, what is X? X is X, Y, Z. Okay. Now, from this I can write A inverse into B. Okay, I will call it as 1. Now, what you can do is we have to find A inverse, right? To find A inverse, the matrix should be non-singular. If matrix should be non-singular, the determinant of A should not be equal to 0, right? So, we have to find determinant of A first. What is determinant of A? I will expand through first row. We will see 1 plus 3 plus 1. You know the signs which are associated with these entries. Okay. So, it become minus of minus become plus. So, that is what we have written. So, now this one 2 plus 3, then it will be plus 1, 2 minus 1. See this 1 into 2, 2 minus 1. So, what is the answer? So, it is 4, so which is 5, which is 1. So, what is the answer? 5, 5 plus 5, 10. So, here the determinant is not equal to 0, okay. The determinant is not equal to 0, since the determinant value is 10. So, we can say that the inverse is exist. if inverses exist, we have to find adjoint of A. How we can find adjoint of A is, so first what you can do is write down plus minus plus minus plus minus plus minus plus and take transpose. Okay. Now that is a matrix. See, if you wanted to find this entry from this matrix, you delete first row, first column and take the determinant of these elements 1 minus 3 1. 1 into 1 1 minus of minus 3 into 1 is minus 3. So what is this? 1 plus 3 which is equal to 4. Okay, this entry is 4. Similarly, this entry. So delete it 2, delete first row, second column, 1 into 2 is 2, minus of minus 3 into 1 is minus 3. So the answer is 2 plus 3 is equal to 5. Okay, this value is 5. Next is this, delete first row, third column, take the determinant 2 minus 1 1. Okay, this entry is 1. So similarly, now we got the first row of the adjoint matrix. Similarly, you can find second row as well. How you can find second row is, similarly you can repeat the same thing. So this entry we have to find. For this entry which lies in second row and the first column, you delete this, that in this first column, second row you delete it, 1 into minus 1 and minus 1 which is minus 2. So here is minus 2. Next is this entry we have to find, right. So 1 into 1 minus 1 into 1, see this entry, right, see this entry, delete second row, second column, 1 into 1 minus 1 into 1 and the answer is 0. Next this delete the second row, third column, 1 into 1 minus of minus 1 into 1 is minus 1, the answer is 2, 1 plus 2, sorry 1 plus 1, 2. This entry is 2. Next is this entry we have to find. So that how we can find, delete first column, third row, minus 1 minus 3 is 3, minus 1, the answer is 2. Next is this, delete this row, delete this row and this column, minus 3, minus 2, minus 5. Okay, next is this entry, so 1 plus 2, 3. And this is what the adjoint of A, since we have transpose. So if you take transpose, so it will becomes what? Adjoint. Okay, this is a cofactor, this much is cofactor. If you take transpose, it becomes adjoint. So if you do so, we are going to have, so 4 minus 5 and 1 and here is 2, 0 and minus 2 and 2, 5 and this 3. Okay, this is what the adjoint matrix. Okay. Now we have to find A inverse. Yes, we have calculated adjoint of A and B is already we have written, and determinant of A is 10, X is we know it, X, Y, Z. Now what we can do is we can find A inverse, right. So what is A inverse? 1 by adjoint of A, adjacent of A is equal to, what is the determinant of A? 1 by 10, which is 1 by 10, and what is adjoint of A? 4, 2, 2, minus 5, 0, 5 and 1 minus 2, 3. Okay. This is what A inverse. Now from the, what is equation 1 we have? That is X is equal to A inverse into B. Okay. So now, which is equal to, what is A inverse now? A inverse is 1 by 10 into, what is that, 422 minus 505 and 1 minus 2 3. And what is b? b is 402. Okay, so now you can multiply this. 1 by 10 into 4 into 4 16, 2 into 0 0, 2 2 4. Okay, 2 into 2 is 4, minus 5 into 4 is minus 20, 0 into 0 is 0, and 5 into 2 is plus 10. Next, 1 into 4 is 4. Okay, next, minus 2 into 0, which is 0. Now 3 into 2 is what, 6. Now what is this? Which is equal to 1 by 10. So 16 plus 4 and minus 20 plus 10 is minus 10. 4 plus 6 is 10. So now you can multiply 1 by 10 to each of the entry after multiplication of A inverse into B. So what is x? As we know that x, y, z. So which is equal to, you just multiply it. What is this? 20 by 10, 2, minus 10 by 10, minus 1, 10 by 10, 1. Hence, therefore we can say, so you can see here we have two equal matrices. You just equate the corresponding elements here. X is equal to 2, y is equal to minus 1, and z is equal to 1. See, these are the values of x, y, z. Understand? So now you can check, substitute these three values in any one of the given system of equations, okay, and that the equation should satisfy. If equation is satisfied, our answers are correct. So with this we concluded the exercise 4.6, and these problems are very important from point of examinations. So what you can do is you practice as much as possible. So it's looking to be so easy, but you have to practice, otherwise you may get confused. If you prepared for the particular problems, you prepared all the problems from the exercise, but once you in the examination hall, so you may get confused. In notes I got this answer, here I am getting this. Such kind of confusion will be there. So to avoid that kind of confusion, so practice as much as possible on exercise 4.6, since it is important for point of examination. So with this we conclude the chapter determinants. So practice well. Thank you. Sai Ram.